Howdy AP PreCal, it is Miss Kosh, and today we are looking at 210 and 211. But to be completely honest with you, I have two good videos actually covering this from last year. The only reason I'm doing this is because one, I caught a mistake. Maybe I caught it in the video last year, I don't remember. But I think it had said that A can't equal 1, A can equal 1, A can't equal 0. Because if A equals 0, the whole thing goes to 0, and it's not a log function, it's now just a horizontal line at y equals 0. So I made that change for this year, and then I think I left it. This is all Mr. Passwater's beautiful work. If I get my act together, I'm dropping things. If I get my act together, I'll post a link down below to the video of me teaching this stuff last year. Look up inverse of exponential functions, maybe, if I forget to do it. That would be what I would go look for. And then page 2, he did a beautiful job with the notes, and I have a video going through all of this from last year. I added an example 5, so I want to do that right now. And then so that was the first video I posted last year would do all the way up through example 4. I'm gonna work 5 in just a second. And then I'm also going to look at, we're doing 211 at the same time. I like what he has here. We can reflect the logarithmic function over the y-axis, and that changes the domain. So what I wanted to do, he has such beautiful work. And anyway, I have a video. What did I call this one? I don't know, look up log functions, or I'll try and put a link to the second video. So what you might want to do is watch the first video in the link, then come back and watch example 5. Pause it, go watch my second video, and come back. And then because he didn't quite talk about what happens when you reflect it over the y-axis, I threw in 3 more examples at the bottom. Okay, so that's kind of our game plan for today. So I hope you'll have 2 videos that I made last year that do the bulk of the teaching. And then right now I want to do number 5, and I want to do the new ones that I added here. Okay, so they say, let me grab a calculator and clear it. They say, this calculator is not turning on. Oh, there it goes. Oh, goodness. I did not prepare. I'm sorry. I just jump right in and start teaching because life is busy. Teaching is busy, all the things. Okay, so I'm gonna come to my graph, clear out whatever. Okay, so here I'm just on my Casio. So it might work. One thing I want to point out to you, they give you this equation, f of x equals 5 times 3 to the x minus 1 plus 2. And then they say that the g of x is equal to the inverse. Well, if you have access to Desmos, to find, like, the easiest way to find the inverse, or to make sure that you found the correct inverse, is to literally just switch your x and y. So Desmos can handle this equation, x equals 5 times 3 to the y minus 1 plus 2. Now I will say, and so then this becomes the inverse, and you don't have to think about anything. I mean, that's kind of almost too easy. But I don't know. I know that Desmos will do this sort of thing. I don't know. I need to play around with the test mode Desmos, because I think it doesn't do as much as what we're used to. But in any case, in my classroom, they won't be using Desmos on a test or quiz because it's just too tricky for me to regulate. So you will get good at using the calculator, but the calculator won't let you do this. Okay, so what we'll have to do is we'll have to put this into, we'll have to solve for y. And so we will say, from here, I've switched my x and my y, and then I end up x minus 2, and then I can divide away the 5. This would be equal to 3 to the y minus 1. From here, I can either think of taking log base 3 of both sides, or I can think of this is exponential form. Here's the base. So we have log base 3 of what? Well, of this x minus 2 over 5. Since it's a fraction, I didn't need the parentheses, but I was on a roll and I wrote them. And that would equal, what would it equal? It would equal y to the 1. So we check by doing I heart logs. 3 to the y minus 1 equals that, and that was what we started with. Okay, however, we haven't quite solved for y. So we would say y is equal to log base 3 of x minus 2 over 5 plus 1. Okay, so now I need to know, where does that equal negative x? Well, so because this, I said y, but I should have said f to the negative 1 of x, or I should have said this is equal to g of x. Okay, so I'm gonna type that in. Now I forget actually, option, calculate. There it is. Okay, I was looking for how I could change the base of my log. Now keep in mind, I can do, so I'm typing that in, log base 3 of what? Well, of x minus 2 over 5, and then there's plus 1. And then okay, so if I forgot how to get this log base 3, I can always do change a base property. And so I could say log of, in parentheses, x minus 2 over 5, close the parentheses, divided by log of 3. That's the change of base property. This becomes that value and this becomes that. And I just use the log base 10. And then I have to, over here, say plus 1. Okay, those should be the same graph. So when I draw that, well, that was ridiculous. Let's go to window. Stop. Okay. Shift window. Okay, whatever they were using that for my, they had test today. What am I wanting to do? Standard. There we go. Let's start here. Okay, we knew that they were the same, but I was just proving it to you. Well, by we, I mean me. Okay, so what we ultimately needed to do is we need to see, let's clear out one of them or turn one of them off. Because I want to see where does this equal y, where does this equal negative x? So in my other graph I'm just typing in negative x. Here's that first graph, here's the second graph. I can do G-solve and find their point of intersection. And they intersect when x is approximately 2.1560. My colleague from last year strongly recommended 4 decimal places, and there we go. Okay, let's keep going in this video. So as promised, you should pause here and go watch the video from last year. And if you don't, it's fine. I'll never know. But, but here we go. So if you watch the video from last year, I will have done these 3, and now I'm going to do these additional 3. Okay, so what I wanted to do here is I threw in a negative. So what does this do to our graph? Well, this gives us a reflection. It gives us, so instead of looking something like this as a log function, we now have just reflected over this, you couldn't see what I was doing. We just reflected over the y-axis. Okay, and so this one is going to look something like this. Or I have an asymptote, that looks kind of terrible. It goes to the point now, -1, 0. It has an asymptote when y equals 0 still. And so what are they asking for on that one? They're asking for the domain and range. The domain is now going to be -infinity to 0. We can't include 0. And then our range is still all reals. So the thing to think about with this one is I can't take the log of a negative, but I have a negative x, so that means I have to have a negative. So all of my domain has now become the set of negative values. So hopefully that helps. Okay, excuse me, let's look at this next one. On K, our favorite letter, we could rewrite this as log of, and I was too lazy to change the bases. I just wanted to type this in and I didn't really care. So I'm gonna rewrite this. I'm gonna factor out a -2. And when I do, the x becomes positive, this becomes a -2, and then it's +5. Now I can see the transformations. If it's like this, you can't really tell. So the negative means that I've reflected over. So I went from this to now this. Oh, that looks terrible. Something like this. And then now I have to shift it to the right too. So my asymptote that was at 0 has now moved to y equals 2. This point that was at -1 has now shifted here like this, and so this is now, okay, something like that is our new graph. They're just asking domain and range, so our domain is going to go from -infinity to 2, and then our range is going to be all real again. Anytime you see log, anytime they ask for the range, it's just all real. So there's no, what could they do? Unless they threw in an absolute value or something, but that would be annoying, so I don't see AP doing that. Okay, so this next one here, I have another that factored out a -2. And so it shifted. Notice the -3 and the 5 don't change. That would impact the y values, but the range is already all real, so they don't affect the range at all. This -2 reflected us over to the other side of the y-axis, and then we shifted to the left one. So now our asymptote had been at 0. We went to the left one. Who knows whatever else is happening, but we're going to go, I mean, this graph is wrong, but actually we had a reflection, or another reflection, and never mind. Anyway, that looks terrible. But the point is, what's my domain? Negative infinity to negative 1. Okay, like, subscribe, comment, let me know how I can help you, and hopefully I will put the links to these other videos. If I forget to, or if I get distracted or whatever, if you would, the first person to comment with that link below gets a well done. I don't know what I would give you. You get a good job. Thank you very much. Okay, go practice.